So we have our cubes. We can fly around and view our cubes. We can easily change our cubes to an arrow by saying make arrow, like so. Build that and run that. And since we're sending down different geometry data, but we're still using the exact same buffers, we get arrows instead of cubes. I want to talk about vertex arrays. I've seen texts or books or articles. They always use vertex arrays, and I notice they use vertex arrays in a lot of places they don't need it. And it makes me think, well, are they just in a habit, or do they not understand vertex arrays? We're on video 60 something in this playlist, and I have not yet once shown you a vertex array. So that should tell you that maybe the first thing we do not need to do is use a vertex array. Let's see if we can understand why we need vertex arrays. I'm going to change this back to making a cube. I want to view the two cubes, but I'd like to throw an arrow into the scene as well. Right now we're just stuck to two cubes. I want to put an arrow somewhere in the scene. So we're going to send some arrow data down, but if we send the arrow data down, we're going to need another vertex buffer, another index buffer for the arrow data. So I'm going to do what every awesome programmer does and copy this, paste it. As soon as I do a copy paste, you should think, oh, we could break that into a function. Yes, we could. I'll probably do that in the next video. For now, I just want to roll with the copy paste to help you understand what's going on here. We have shape, we make a cube. Let's assign shape. After we've cleaned up shape, I want to say, hey, make an arrow. Do I have a curly brace? Nope. Make an arrow, and let's generate another buffer, but we will need a new buffer. So we already defined vertex buffer ID. So we'll just reuse vertex buffer ID from my previous attempt here. We'll generate a new vertex buffer. We'll bind that buffer to the array buffer binding point. We'll send the data down for the arrow. Shape is now an arrow. So everywhere you see shape in here, we're talking about arrows. We don't need to redefine this. We can reuse the index buffer ID. We'll send down the index data. The thing that will vary, though, is the number of indices for cube is definitely different from an arrow. So I'll F12 on this, and I'll say cube, Control-Shift-U, num indices, Control-L, Control-VV, and we shall say arrow, num indices, Control-minus, minus, minus, to get back to where we were at. At this point, it's cube, num indices. And down here it's arrow num indices. And so we now have 4 buffers, 1 for the cube's vertex data, 1 for the cube's index data, 1 for the arrow's vertex data, and 1 for the arrow's index data. Let's see if we can actually paint both of those. We shall come to Paint GL. We have our full transformation matrix that we create from the view to projection, world to view, and then we throw a model in here. I know I'm flying through this, but this should be old hat from previous videos. Essentially, we get the model transformation matrix, combine it with the world to view, and then view to projection matrix. That makes our full transformation matrix, which we uniform down. And then we say draw. That's going to be cube num indices. And then same thing here with cube 2. We shall do cube num indices as well. But we have a different model matrix for the second cube. Let's see if we can do the arrow. Okay, let's see if we can do the arrow. We can reuse the world to projection matrix. We just need a new model matrix for the arrow. I think I'll just push the arrow into the scene in front of the camera, which means we shall put the arrow, shove it down the z-axis. So mate for arrow model to world matrix gets glm translate. And I know I've been passing these vec3s in to translate, but I forgot. There's an overload of translate that just takes 3 floats. So we should be okay. That's a template argument T, but we're going to use floats. So nothing in the X, nothing in the Y. I want it all down the negative Z. I'll guess negative 3.0. F, and then same logic that we have for the cubes. I'll copy and paste like I know what I'm doing. Control V, arrow to world matrix. I'll copy that. We shall combine the arrow to world matrix with the world to projection matrix, making the full transformation matrix. Uniform that down, and then call draw elements, but it's now going to be arrow num indices. So in theory, we should have 2 cubes and an arrow show up in the scene at the same time. Control F5. Let's see how this works. And our cubes are gone. And we have 3 arrows. Is that what you expected? I told you we should have 2 cubes and 1 arrow, and now we have 3 arrows. What's going on here? What's going on here? Pause the video and think about it. You need to think about this to exercise your brain. So pause the video, think about it, and then unpause the video, come back. The problem sits where we send our data down to OpenGL. We say, GL, generate a buffer. So here's our buffer. Okay, recall, we've talked about this in previous videos. Go look at the videos prior in this playlist about buffers and buffer binding targets and that sort of thing. This is our buffer object. We then say bind that buffer to the array buffer binding point. So here's the array buffer binding point. We bound this buffer object to it. Then we say buffer data, which actually allocates the buffer data that we will stick our vertex data in. So this will be the cube vertex data. You know, I don't really like that. Let's actually type it. Why not? We have a typing tool. Okay, this is the cube vertex data. And then we do some stuff here I'll get back to a little bit later. We also do the same thing down here, but we do it for the element array buffer binding point. So we generate a buffer object. Here's another buffer object. We bind that buffer object to the element array buffer binding point, element array buffer binding target, whatever you want to call it. Element array buffer binding target. We bind this buffer object to it. And then we say buffer data, and we send down our index data, which actually allocates the buffer, and all the indices, the undefined shorts, will be stored here. So this is cube index data. Now don't blink. I cleared off part of the screen there. Let's look at the arrow now. Okay, we're going to send the arrow data down. The process is pretty much identical. We generate yet another buffer object. So here's another buffer object. And then we say bind to the array buffer binding point. So this binding point is no longer bound there. It is bound to here. We bind our new buffer to the new buffer object to the array buffer binding point. And then we say buffer data. Here's all the data, the vertex data for the arrow. So that actually creates our buffer. This is the buffer. This is the buffer object. Buffer object keeps track of the actual buffer. This is our arrow vertex data. And then we do some stuff here I'll get back to, but same thing with the index buffers. All right, we make another buffer object, and we send the data down for the indices for the arrow. Oh wait, no, we bind first. We bind our element buffer binding point to this buffer object, and then we send the index data down, the unsigned shorts for the arrow. We send that down here. So arrow index data. And then we're good to go. Now I want to focus on the VertexAttribPointer calls. All right, and this is copy and paste at its best. First of all, for the cube we said enable VertexAttribArray 0 and enable VertexAttribArray 1, and we've seen why we've had to do this. Well, then we come down here and we do the exact same thing again. We no longer need to do this. Okay, it's just redundant because we already enabled it right here when we did it for the cube. So I'm actually going to remove, I'll just say Control L, remove those redundant lines. We no longer need to enable that. But there's a bigger problem. There's a bigger problem. In fact, I'm going to group these enable calls together. Let's look at this VertexAttribPointer. If you recall this VertexAttribPointer call, it sets up where the data will be streamed from to render our object. Okay, for attribute 0, it's 3 floats. The stride is vertex byte size, and start at byte 0. Then for attribute 1, it's all the same, 3 floats, the same exact stride, but we need to start 3 floats into the buffers. So these two attribute calls set up where the data is going to come from. Now at this point, we're bound to the buffer for the cube. All right, let me bring this back up. At this point in our code, these binding points, the element array binding point, let me get all this. The array buffer binding point is bound to this buffer object, And the element array buffer binding point is bound to this one, so the cube data. And so when we do our glVertexAttribPointer calls, attribute 0, that will be sent down to our shader, will pull from here. And then attribute 1 will also pull from roughly the same location, 3 floats in, but they'll walk down the buffer object using the stride. We've talked about the stride in great detail. But then look what we do. Look what we do. Right here, we say, well, bind these buffer objects to these binding buffer points. So we break these connections. Our attribute data pointers are still pointing right here, though. We're fine for now. But we bind these buffer binding points to different buffers, which is fine. We're using different buffers depending on the geometry. But then we turn around and say, hey, you know what? Let's do the attrib pointers and change these. Okay, well, let's change what attribute 0 and attribute 1, where we are going to pull the data for attribute 0 and attribute 1. We were going to pull it from here, but now I'm telling you to pull that data from these buffers down here. Well, attribute 0 will start at the 0th byte for the arrow vertex data, not the cube vertex data. And attribute 1 will start 3 bytes in, but pull from that same buffer instead. And then we leave it like that. We leave it like that. So that's the state of OpenGL. So when we get down here to PaintGL, and we say, hey, draw elements, and we think we're drawing a cube, the data is going to stream from the buffers that have the arrow vertex data. It won't pull from the cube vertex data. It'll pull from the arrow vertex data because I said attribute 0 is pointing there and attribute 1 is pointing there. And then when we say draw elements, well, that pulls from the buffer object that's bound to the element array buffer binding point, which also happens to be the arrow as well. So even though we're saying cube num vertices and cube num indices, that doesn't matter. We're pulling the data from the arrow vertex data. If I get this back off the screen and rerun this, and fly around a little bit, you'll see that not all of the arrow is rendered. Only part of the arrow has rendered. The arrow has many more indices than the cube does, so we actually got lucky here because we didn't do an out of bounds kind of thing. But we also didn't render the full arrow. Okay, this arrow that's in the middle, we rendered the full arrow because we used the number of indices for the arrow. But over here on these other outside arrows, we use the number of indices for the cube. Okay, what we have to do is set up our attribute data pointers every time we want to render. If we want to render the cube, we have to re-attribute for the cube. And then if we want to render the arrow, we have to re-attribute for the arrow. Oh, what a headache. What a headache. But that's what we have to do. That's what we have to do. So let's grab the attribute calls for the cube. In fact, we don't even need to put them in here because they're not going to buy us anything. So I'll Control X this. And down here in PaintGL, this is where we do the cube stuff. Let's say arrow is right here. And then everything above that is cube. Hopefully you turned up to high definition. This will be cube. So before we go doing our matrices stuff, let's set up our attribute calls. I'll say glVertexAttribPointer 0, blah, 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 blah. But I have to make sure I'm bound to the buffer that the cube data is in. I need to be bound to these buffer objects, not these buffer objects. Well, it turns out we didn't keep the handle or the int for those buffer objects. Here we just said vertex buffer ID, and then it vaporizes out here. So let's actually cut this. And then up here I'll say vertex buffer ID, but I'll say cube vertex buffer ID. We will also need to keep track of the cube index buffer ID. Index buffer ID, and then we need to do the same with the arrow. Copy this, paste it, alt drag, arrow vertex buffer ID, arrow index buffer ID, and then down in here we'll say cube index. Right here we can get rid of this one right there. Cube index. So we're keeping track of the IDs for the individual buffers. Vertex, index, arrow, vertex, buffer ID, arrow, vertex, buffer ID, arrow, index, buffer ID, arrow, index, buffer ID. Whew! What a workout. And then here in the paint, when we say we want to do these attributes calls, we have to say, hey, GL bind buffer, GL array buffer binding point, rebind that back to the cube vertex buffer ID, so that when I do these attributes calls, you are going to point into these buffers and not into these buffers. I want attribute 0 to come from this buffer, attribute 1, same thing. So I have to bind the cube vertex buffer ID back and then do my attribute calls after making that binding. Hopefully you're seeing OpenGL as a state machine. We have to set up all this state and manage all the state, and it's kind of tricky sometimes. So there's a cube vertex. Now before we call draw elements though, we have to rebind the cube index data back to the element array buffer binding point. So GL bind buffer, GL element array buffer, cube index buffer ID. What'll work out? Okay, now when we're done with the cube, what do we have to do? Well, we got to do it for the arrow as well. So same thing down here, but we can, let's be dirty and copy and paste this. Let me get this off the screen. And then down here for the arrow, instead of binding the cube vertex buffer ID, we need to bind the arrow vertex buffer ID and arrow index buffer ID, and then we'll render the arrow. So pause the video, think, is this going to work? Okay, I know this is kind of a complex idea, complex topic, but it's really critical that you understand these buffers and the pointers and the attributes, and where's that attribute being streamed from. And we set up the pointers, and they point to the buffer that's currently bound, and if we change what buffer is currently bound, that doesn't change where our data pointers are pointing to. Pause the video, think about what's going to happen. Control F5. And voila, we have our two cubes, and there's an arrow stuck in the middle there. Here, I'll fly into the cube, and we can see the tip of the arrow. This is kind of an awkward situation for shapes to be in. I actually feel bad for these shapes, but there you go. Now, what does this have to do with vertex arrays? Well, I still haven't used vertex arrays, but I've pointed out a problem to you that this attribute data needs to come from somewhere, and we have to do all these attrib calls. Well, the attrib calls are headaches. They're headaches, but in the next video, I'll show you how to remove the headaches by using vertex arrays.